Are there any questions on the assignment for chapter 19? All right, I'm going to move on to introduce data structures in the Java API. In chapter 20, we're going to introduce lists, stacks, queues, and priority queues. So these are the data structures in the Java API. And actually, in most programming languages, and these are the standard data structures in C++, in Python, in so any of this, the mainstream programming language, you can get all this data structures already in the API. So in Java, Java is an object-oriented programming language. So a data structure, what is a data structure? Data structure is an object. And this object contains a lot of data. So just one object, it contains a lot of other objects. So this is a data structure. So why it's called a data structure? Because it has structures. It has the way to organize the data. And depending on your application, you can choose the right data structure and for your work. So the data structures here we already used is the Arraylist. That's Arraylist. Arraylist is like array, so you have all the data put into the Arraylist, and you can access the elements and using an index. So its internal implementation, it is also an array. It's array behind the scene. So if you know when you use array, it's have fixed size. So when you create array and using new, that's for example, string brackets 100. So that 100 is fixed size. That's array is fixed. Doesn't matter how many strings you are put into this array. You have this 100. If you have more, and then you have to create a new string. So for this array list, it's internally data is stored using an array. If you have more strings, so it automatically creates a new string, and by copying the existing data into the new string, and discard the old array. All right, so we're going to go to this now, chapter 20, and look at this, how Java designed this data structure. So overall picture is this is called Java Collections Framework. So this is a very well-designed API for data structures. You can see it and appreciate it, and after you go through all this material. So first, we're going to look at this is the overall picture. This is the overall design. So this is just the essential design elements here. There are more details. We cannot put all these details here. There's no room, and also it's kind of distraction. So we put all this essential elements here. You can see this is it's the framework. So this is the term in the software design. You have a framework. It's at the high level, and at the framework, this is a collection. So collection, this is the interface. This is the root interface for all this collection data structure. See, we can see right here, we are familiar with Arraylist. Arraylist is a collection. So this is a collection of things. You're going to put all this data in the collection. So, but that collection is the Arraylist. All right, so here we have, this is all the interfaces. And this is the most general interface. It's called collection. And then you branch into specialized collection. It's a set and list and queue. And further, you can look set, we can have a sorted set. All right, so this is a navigable set. So you can see this is the design. It's more refined and going down. So it's more refined going down, and all the way here down to this section, it is the concrete classes. So these are the concrete classes, and those are the ones you're going to actually use it to create your data structures. And there are common features, and they are generalized in this going up, and this is all the way to this collection. So let's look at this example here. You can see this how it works here. First, I'm going to show you this UML diagram for collection. So what is in the collection? Collection here is interface, and you can see this is the collection here. Hey, all these methods, the abstract methods here. So here's you add a new element O into this collection. So please note that we're using the generic types. Here's generics, here's E. So it's any object type. So here's add a single element. So what is the next one? Add all. This is add all the elements in the collection, in this collection C, to this collection. In the collection C into this collection. So when you invoke this add all, you already have a collection C1 dot add all C2. So like this. So now you see the syntax for generic type is here's a collection is any subtype of E. So this is question mark extends E. See, that's right here. All right, so here's clear. So it's just remove all the elements from the collection. And this is contains return true if this collection contains the element O. So it's just test if this element is in the collection. And this is contains all. So you're going to check if this collection contains all the collections in this. When you invoke it, is something like the C1 dot contains all C2. Equals. Okay, so look at equals here. It's overridden in this collection here. You can see here how to compare two collections. Here is hash code. So that's the hash code, how you get the hash code of this collection. And this is empty. Test if this collection is empty. Remove O removes this element from the collection. And remove all. So the difference between remove and remove all is you have another collection, all the elements from the another collection. Retains all. So retains all is this. So you invoke a C1 dot retains all C2. It's going to retain the elements that are in both C1 and C2. All right, size. It is to return the number of elements in this collection. A two array. So there's two methods. Look at two array and two array, and this is very similar, but there's a difference here. So you have a collection. You return an array for the collection. All right. So here is two array. So two array here. This with this overloaded method here is you're going to send this collection into this T. So T is the one target. All right, so you may notice that we have this here. Interface, this is interface, is a subtype of another interface. This is called iterable. So any collection is iterable. So by iterable, we mean that you can traverse the elements in the collection through this iterate. So here is the iterate. So there is iterate you're going to use, iterate. So there's a for each method. We're going to perform action for each element in the collection. All right, so here's interface for the iterator. So here's, look at the iterator, returns the data type is the iterator. So here is the iterator. So you're gonna have next, next, remove. So this is iterator. You can think about it. Actually, you have this input stream is an iterator. So you're gonna have traverse all the elements in the stream from the beginning to the end. So this is through the iterator. All right, so I'm going to write a test code for this. You're going to see this, writing a code, test it out. I'm going to test all things. So go and look at the UML diagram. We have that picture. And here, this is, we also have that overall, the framework. We have the collection, and so collection interface, and we have the concrete classes. And we're going to pick one. It's the Arraylist. So I'm going to use the Arraylist here. So here is my Arraylist. It's a new Arraylist. So this new Arraylist, look here, it is a collection. So I call this collection one. So this is Arraylist, and here is a string. So let me just write something here. You're going to see here. I can just call this. Okay. All right. I can call this. You can add New York to collection one, add Atlanta. So add Dallas. So this is the Arraylist. When you add is append to the end. So here we're going to add Madison to collection one. So now you have this collection one dot add Madison. Okay, we're going to print everything. So this is all fine. You're going to get everything. So if you look at the output, you're going to see this is New York, Atlanta, Dallas, and Madison. So here it's returned. This is the same as toString here. So it's this toString here. The toString is representing a string representing for all the contents in the Arraylist with the square brackets. So you're going to see this is something returned. It's printed out as this brackets. Okay, New York. And next one is Atlanta. So all this is printed out. Okay, so here. All right, next, we're going to see, hey, is Dallas in collection one? So how you can rewrite this? Okay, using this collection one dot. So dot what? Remember this contains method. So contains method, that's the one we're going to use. See, we have it. All right. So now the next, we're going to remove Dallas. This is all fine. Remove it. And here you get the size now. So what's the size now after you remove Dallas? All right. So it's becoming 3. Now it was 4, now becoming 3. So now this is 3. All right, so the next, let's have another collection here. So here is a collection. So Seattle, Portland, Los Angeles, Atlanta. All right, so now we have this collection 2 printed out. So what I'm doing next is this, it's a clone method. I'm going to clone, so call this clone method. So this is all the data structures we have has the clone. You can clone a new data structure. It's get another one. So this is this time here, we're going to get this and clone it and get this and clone of collection 1. It's called a C1. So we're going to add all elements in collection 2 to C1. So we're going to add all elements C1 dot. How do you add all elements from collection 2 to C1? So this using add all. Okay. Collection 2. So please note that the difference. If you use this add, so it's single element, it's actually not going to work because this one here, it's the data type is not a string. You have to add a string. So this is add all. Okay. All right, so now you can see this. We're going to print C1. So what is new C1? So here we're going to have this collection one and dot clone. So we get a clone of collection one. It's a C1. So using retain all is, so you have the common elements both in C1 and C2. So they're retained in C1. So we're going to print. So what is this common cities in collection one, collection two is in C1. So here's C1. All right, so here another one's removal. So we get a clone of collection one. So we not destroy collection one. So we're gonna new copy C1 dot remove all. So remove all, and we have this collection two. So remove everything in collection two from C1. So this is here. And now you can see this here. Everything is here. Now I'm going to go back here. You notice that I changed this to collection. So it is, you can see this is if you run this code, I think there's somewhere, because maybe I have this is, I'm going to try this, okay. It should be okay unless you invoke a method that's specifically for Arraylist, then you have a compile error. So that's the only thing here, and you can see this here. I'm going to compile and run. Okay, so yes, we have this error because this is the clone is only in the Arraylist. So here you're gonna to Arraylist, or you can have another way to do it is this. If you want to stay with this, when you do this clone, so the clone is here. Okay, you can do it is you do a casting, then do a clone. So what you can do is do double casting here. So that is something you can. So you can say, I'm going to cast this into Arraylist string. Okay. So this is just the kind of output. Yeah.
I have a question.
Yeah. Okay.
So you know how collection is an interface in the Java collections framework. It does. So you just said that it doesn't have it, or it doesn't expose the clone method, but a lot of the data types like Arraylist do have their own. Is there an interface that has that method that they all implement that we could cast to instead?
No. See, if you look at the API here, I'm going to show you here. It doesn't have a clone here. There's no clone here. There's no clone. You can see there's no clone for the collection. So, but you go, okay. If you go to the Arraylist, and so I'm going to show you here. If you go to the Arraylist somewhere here, I'm going to show you here. So if you look at this Java dot util dot Arraylist, okay, just do a Google search for that. So you look at the Arraylist here. So the Arraylist has this clone. We're going to see this is because this is the one here is
clonable. There it is.
Yeah, clonable. So it has clone. Okay. All right. So that's
thank you.
Okay. So if you go back here now, you see there's always ways to rewrite the code. You can cast this collection one into this Arraylist and then apply the clone method. That should work. Okay. So this is here. All right. So you can look at the note that and all the concrete classes in the Java collections framework implement the java.land.clonable interface, and also this interface, java.io.serializable interface. So serializable means they can be serialized. Serialized, that's very good because you can use the object IO. It's very powerful mechanism to dump the whole object and into, your output device. Okay, so this is all, except there's a priority queue does not implement clonable interface. Yeah. All right, so here's the self-check, everything here. So this is just the beginning of the introduction for this, all the data structures. And next, we're gonna get into this iterator. I'm gonna show you how to use the iterator. So that applies for all the data structures on the collection iterator. And then we're going to show you new data structures. So here we already know Arraylist, and next we're going to use linked list. And then from that, and we're going to introduce the stacks queues and priority queues. And so then the next chapter we introduce sets and maps. Okay. All right, I'm going to finish. This is the now this class. This is just a short lecture, and so we have the Google people presenting this recruitment. So I hope you enjoy this. All right, if you have questions, and please stay. Okay, otherwise, feel free to leave.
Professor,
Okay.
can I add something real quick?
Yeah, I'm going to turn off the recording. So, okay.
If you
Yeah, go ahead.
guys want to have your resumes reviewed,